Thanks for the introduction, Mang. So this is the one of our projects that we started 3 years back when we started a lab, and then we figured out what will be our topic for next, the 5 to 10 years. So this is about the smart data pricing, that $10 per gigabyte, and we started with a colleague 3 years back, and then we now spun out, and then we have a startup, DataMi Incorporate, just 5 minutes from here. So as Moon mentioned, this is a driving force that there are lots of widespread adoption of the handheld devices, and also data hungry application, and also the high resolution devices made it the huge rapid growth of the demand for mobile data. So and then the 2 or 3 years back, that end of the unlimited mobile data plan in summer 2010 from AT&T. And also from this year, 2013, there is no available spectrum. So the recent report to the PCAST report to the president that recommend using the unused government-held spectrum to spur economic growth in the U.S. So, and then also because of this huge demand, that now the ISP also suffer from their revenue. So because of this huge demand curve, that their costs also increase quite a bit, and then their profit margin actually decrease significantly. So then how about the consumer side? Consumer also they feel like they are victims, because too many data plans, and also too many devices they need to deal with. So, and then also there are the countless number of the application. So they have no idea that how they utilize this whole innovation in their daily mobile usage. So then you may wonder, what is smart data pricing anyway? So smart data pricing can be more than a flat rate. The usage-based pricing or metering and capping that usually done by the ISPs, and also charging based on time and location and congestion-dependent pricing, and also charging differently for different applications, and also the sponsored content, and also charging based on your quality of the service or quality of experience you got, and also quota-aware content distribution, and any combination of the above. So basically, that smart data pricing is actually charging users based on the bytes real cost. This is our DataMi project aimed at. So then you may wonder that there are lots of the work has been done in the ISP's core network. So what's where to innovate? So what we visioned is that we revisit the architecture division between the cellular core and the end user devices. So since 1G, that all the control has been done on the ISP's core networks, because of lack of the demand for personalized control or some more intelligent service. But now time changed, because people want more intelligent service for individual users. So even in order to implement some kind of app-based pricing, that just using the handling from the ISP core is not enough. So we vision that end user devices that need to be in the picture for future pricing innovation. And also, we also leverage end user intelligence to alleviate congestion. So we actually the lots of physical layer or some MAC layer algorithm that alleviate the congestion. How about we use the application that actually give some kind of long-term congestion alleviation, and also more intelligently, and also many different applications have many the different time elasticity that we can exploit for this direction. So this is our DataMi logo. So so we provide 3 solutions. One is facing end user. So educate consumers on their mobile data usage. we rolled out the DataWiz application that have more than 200,000 users across 122 countries worldwide. And also, we have an end-to-end prototype that providing the time-dependent pricing for the ISP and end users. And also, we do data intelligence service that providing value-added service for the ISPs. So I will focus, first two in next 10 minutes. Okay, so first one is empower users with DataWiz. So this is our DataWiz applications that is available in both iOS and Android. That we have now more than 200,000 users worldwide, and it provides the when and where and how much the data you used. And it actually provides the location and where you use the data, and also the distribution of your usage over a day, a week, and months. So you help the user to control their data, and also the providing the prediction for helping users take their data in monthly use. Okay, so as the next step, we recently rolled out the shared data plan. So what it does, currently AT&T and Verizon provide the shared data plan, but there is no effective, mechanism can show the user to have some how their data is shared by their family members. So we actually build the fairness into the system. So we show how each individual of your family they share the data, and also allow the priority among your family members, and also have dynamic planning to increase the efficiency. So for example, the Chris and Alice and Bob, and there is some kind of distribution of their usage that actually can fail fail location among these people, and also applications. So this is some of the screenshots that we will show in our demo soon. So it will show the different family members, the usage over time, and also it shows the distribution of their usage for a day and week and months, and also their usage distribution among the family members. So what it does, that we help users, that empower users to manage their data more efficiently. And then help ISP with a Tube. So Tube is a solution that's providing time-dependent pricing. So this work has been presented at SIGCOMM last year, and so this is the 24 hours network usage. So as you can see, there is a huge differential between the peak and average the ratio. How we can exploit this, opportunity. So there are this is the application that typically you can find from the mobile application. So there are movies and the cloud. A software update can open wait a couple of hours. So a couple of hours is enough to shift the usage. Even shifting the usage several minutes is quite helpful to alleviate the congestion in the networks. So what do we ultimately want? So we have, this is the 24 hours, the usage. It's like an iceberg that we actually want to chop off the peaks and then raise the sea level. And then ISP can, cost reduction that reduce the cost that involve the purchasing more spectrums. And also the users, before this time-dependent pricing, actually it has more choice, and they use more and they pay less. So let's see how time-dependent pricing works. So this is the time. This is the cartoon illustration of the how time-dependent pricing works. So this horizontal bar on the top is a price discount. That green means higher discount, and the red means negligible discount. So as you can see here, before the time-dependent pricing, the peak-to-average ratio is a 2.2, which basically means the peak usage is more than twice the average. So one user in the network, it's a Dropbox sync to the next time of the higher discount, and then we have this curve. And then accordingly, more user involve this time-dependent pricing, that finally the peak-to-average ratio reduced to the 1.53. This is a 28% decrease in peak-to-average ratio. So I only show the 3 applications. As you can imagine, the many users or many applications, that time-insensitive applications to later times, that we will see this peak-to-average ratio will drop even more. So this is our system's feedback loop. So just imagine you are time-dependent pricing users. So you install the application on your devices. So you check the prices for next 24 hours. So you know when is green and when is red. And then also you decided based on the color-coded price discount available to the user, or you just let the devices decide it automatically on behalf of you. So we call this as autopilot, that I will explain later. And also, as you can see, that ISP server need to compute the right prices so you are willing to take it. But there is a challenge here. If the ISP doesn't incorporate how people respond to the prices discounted, then ISPs end up just shifting the peak to the different times of the day, which is undesirable. It's like in a chess game without considering the other people's move. So that's why we have a user behavior estimation. This is a kind of the machine learning. And then, based on this learning that we feed into the price calculation, and then ISP server feed back that information to the user interface. So among many steps that I will show you, one important step that we estimate the user behavior. So suppose that we have 3 applications and 3 users and 3 applications, and then different colors, the different users, and different shape is a different applications. So what we want is put the application into different bins of different inpatient. And then we measure the mu of the average usage on each bin, and then we calculate the weighting functions. So based on this weighting function, that you can see this, the gamma 1 and gamma 2. But it's very complicated, but you can read our SQL paper. So what basically our price computation is a minimizing cost by summing this 2 gamma 1 and gamma 2. Okay, so this is the some overview. So this is the architecture that how it really works. So this is the user devices, and then that is ISP server. So user device, you see the price for the next 24 hours, and then also the application is measured on each user side, and the server side that there is an aggregate traffic measurement and also behavior estimation using weighting function, and then price optimizer, and then those prices calculated from the server is fed to the user devices. So here, server-side design, it looks very complicated. I will not explain whole detail. So I will just highlight a couple of blocks. So as I mentioned, there is a measurement and user behavior and price optimizer actually run on our server. And also, we use a MATLAB and the convex optimization package that calculate the prices offered to the users. And also, we provide the REST API that support any kind of devices that use the web as an interface. So currently, what we support is Android and iOS, and also Windows, and etc. Also, there's a very complicated client-side design that we provide top 5 application display and the usage and price, and also status bar, and also the usage tracker, a session recorder, many pieces. So the shaded block that I emphasize here is actually requires tight system integration. So Android that we actually can do without modifying any existing infrastructure, but the iOS that we had to jailbreak, and we have to find the way to implement all those blocks. So here we actually recruit the 50 participants from the Princeton community who are AT&T 3G data plan users, and then we pay their bill to AT&T, and then we charge the participant according to our time-dependent pricing. So this is the architecture that people installed our application, and then all the data we use a specific access point name that actually redirect all the traffic into our lab, and then from our lab we measure, and then we compute the prices, and then we send that price to the user, and the user react to the prices by themselves or by using autopilot mode. So we did not capture any voice traffic because the path the voice takes is actually different from the data. So this is some of the screenshot that we captured during our trial. So as you can see, the 24 hours that you actually can see the 24 hours price discount and the usage, and then also the current bill, that how much you used so far. And also there's an application tolerance you actually can set. And for example, you may set some of the video application that can delay longer. And also, we provide a parental control that let the people don't use in certain time. And also, when your budget is reached to a certain point, it actually has some kind of reminder that whether you want to still use it or not. So after the time-dependent pricing, that we knew that the peak to average ratio that reduced it by 30%, and then the overall usage increased by 130%, which means for ISP, there's some kind of potential that actually can increase the users the usage. So we have the several ongoing trial with Reliance and MTA and other vendors. And so this is the more information. That please visit our DataMi.com, and then also welcome to the any questions.